Welcome. So I hope in the previous video I was able to show you the importance of uh, being fair, yeah, fair in your data, like the importance of fair data. And as I mentioned, you cannot be fair if you don't have a good data management practices. And that's what we will try to just like learn in this lesson. And that's also is part of that's part of your your work, like your research work. That part of your research work, that would be part of like your research like proposal. If you are doing any research proposal, then that would be part of the research proposal, is to provide like with your proposal a data management plan. Yeah. So now, since you have appreciated like how fair practice will like enhance like collaboration, research transparency, and even benefit you, because like when you go back to something, you will have all the details and you don't need to reinvest these efforts that you have already invested. Same with the efforts that was invested in your research lab or your company or whatever. Okay, so by the end of this lesson, you should be able to outline like key elements of like a data management plan. And key elements is just something simple. You just need to, in a simple word, you need to know like what type of data you're expecting to get, like formats of data, yeah. And you are also expected to know what is the size of this data, yeah. And if it's a huge data, what I'm going to do with it, yeah. And what is the best practices for managing this data, including archiving the data for future use. Like, and by future use, I mean like whose future use you comes first. You could be the one who could use it in the future. You could be that person, yeah. No, not just future use by your research lab or your company or by uh, the general scientific community or like your stakeholder, but you be the first one who will use this, yeah. You might be, yeah, I don't know if you will, yeah. Okay, so let's and then you should be able to prepare like a data management plan for your research proposal. So how to be fair, to manage your data, like you need to manage your data, develop and implement a good research data management practice, and then you share your data following the fair guiding principle. And that's I will show you like this video. I will show you this one. Next video, I will show you like this one. Okay, so you see this table. What I will do now, I will go in this table one by one. Yeah. No, I'm not gonna do this. Okay, but actually you will do it. But what I want you to do, this is a survey. Yeah. So what you can do, you can like fill out this survey with your mobile phone, or just like click on this link. Like if you clicked on this link here, it should be able to open out like this survey for you. Yeah. And because I want you to read it, but let me just, this will show you where you are standing in terms of like your data management practice. So that's basically what I want you to know. Like that's the objective of filling this survey. I want you to know where are you now. Like so, let's do an example together. So I will just do like the first one together, but then you will read this on your own. Yeah. So the first one is like planning your project. So this is ad hoc, one time, active and informative, and this is optimized for reuse. So that's like the best practice, and that's like ad hoc or whatever. Uh, So when it comes to my data, I have a way of doing things, but no standard or documented plan. So I don't have like a plan. Yeah. One time, I create some formal plans about how I will manage my data at the start of the project, but I generally don't refer back to them. Yeah, so that's like one time. That's like you prepare a data management plan just as a requirement, like a checkbox. Yeah, active and informative. I develop a detailed plan about how I will manage my data, that I actively revisit and revise over the course of the project. Yeah. So that would be like active and informative. Yeah. Uh, and optimize it for reuse. I have created plans for managing my data that are designed to streamline its future use by me and by other. Yeah, so that's like optimize it for reuse. And that's what I generally do. And I showed you an example like when I did this like environmental data science exercise, uh, I, I I planned it in a way that like if anyone want to continue this work in the future, they can easily pick it up. Yeah. So I want you to fill the survey. So that would be like your first survey question here. Yeah. Like you will see like planning your project. Like, are you here, 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 or here? And again, like this is, I mean, this is just for your information. So basically you gauge where you are. Yeah. And the second one is how you're organizing your data. The third one is saving and packing up your data. The fourth one is getting your data ready for analysis. Fifth one, analyzing your data and handling outputs. And like the last one is sharing and publishing your data. Yeah, so that's like more like detailed of this one. Yeah. And so basically, I want you to read this so that you'd reflect on your data management practice and also learn the best practice. Yeah. And you see where you stand on this chart. Yeah. Okay, so do this, and in your homework, I think you have to upload like make sure after you submit the survey to save the screen. So after you submit, like you will do this here, you will click submit. Don't submit the survey itself, but save like the confirmation screen, upload it on Canvas, and then that's how you're gonna get credit for this exercise. Yeah. Okay, so now you learn it about like if you completed this, you will learn about like what is a good practice here for handling different parts of your data. But now what I want to do in the rest of this lesson is that I want to show you an example like of a data management plan. And I will show you example from NSF, like National Science Foundation. So National Science Foundation, they have guideline on dissemination and sharing of research letters. So NSF data management plan requirement, like when NSF requires you to prepare a data management plan, what do they require? Each directorate will be different. So like I listed here two directorate, like the engineering directorate and the geoscience directorate because I have a joint appointment with engineering and the water school. So I'm also a faculty at the water school. Yeah. But I teach this course mainly to engineering students. But just for if you are also if some students from the water school is watching this, they can also check the geoscience directorate. So the data sharing policy, let's just read this together. Yeah. Investigators are expected to share with other researchers at no more than incremental cost and within reasonable time the primary data. See, so like what they do, like primary data, like that you collected, yeah, samples, physical collection, and we know like how we can do this physical collection, like this persistence. It has like a certain persistent identifier. I don't remember its name, but you can go back to this slide. I mean, we can remember it together, yeah. We can go back together here. So remember, like you do this, how you make this findable, like if you have it's international generic sample number, and that's where you will put the metadata of this sample, and you will provide like information about this sample. If somebody want to access this sample, how can he or she like do this? Yeah. So let's go here. Yeah. Uh, Physical collection, and other supporting material created and gathered over the course of the study. So other supporting materials created, that is very wide. So other supporting material that could include codes, that could include like analysis steps, that could include software, that could include reports, that could include publications, that could include posters. And I showed you like an example of where for one project, which I'm like the PI, the principal investigator of, how we have like a website for the project where we share like these supporting materials, yeah, like some samples of our code and results and the publication and the project team and project progress report and all these information. Yeah. Gathered in the course of the project under NSF grants. Yeah. Uh, NSF data management plan requirement. Proposal must include a supplementary document no more than 2-page label as data management plan. So you should do this. I just did this like recently because we were submitted an NSF proposal and actually we were lucky it got funded and we submitted it under this National Geoscience Directorate. So I will just go to this directorate guidelines and I will check what they need and I will do it accordingly. For your case, you might not be doing NSF. I'm just giving this as an example. For your case, you could be doing other funding agency, including a non-profit organization, including other companies that you deal with, including like state agency. So you need to check carefully in your bid or like your request for proposal or request for application or whatever uh, you are doing, you need to carefully check what is like if there is a requirement for a data management plan, and you need to check what are these guidelines, what are these requirements. Yeah, but here this is just an example. Yeah, but if you are doing like a construction bid and then your engineering company requires data management plan, it will follow like you need to study this carefully, yeah, and you need to do it according to the guideline. Yeah, if you are whatever, yeah, consultancy office and you're working for a project for uh, state agency or non-profit organization, same thing. If you are an engineering company and you're working for the owner and the owner has a specific requirement with the data management plan, you should check this. Yeah. Okay. Let's move forward. So again, this is just like an example from NSF, but for your future engineering or research project, you need to check uh, the requirement of your funding agency. But here, this is like this is the one that like this. I think this is the engineering one. So let's just read this together. Proposal must include document of more than 2 pages uploaded under data management plan and may include like so that's what they require you to include like type of data. Like if you are doing samples, like if you are doing physical collection, like water samples, for example, like physical collections, like you are collecting a core, like you're doing drilling and collecting a core, software, curriculum material, if you're doing education, yeah, so you need to include curriculum and other material to be produced in the course of the project, yeah, like reports, like that would be PDF, for example, presentations, that could be PDF or PowerPoint or whatever, yeah, Python code, that could be like a Jupyter notebook, AutoCAD drawings, that would be like AutoCAD extension, whatever that is. GIS drawings, that would be GIS extension, whatever that is. Yeah, GIS maps, not drawing. Yeah, and so on. Yeah, so that's the type of data. You need to specify like what type of data, and then you would know what would be the best, because like this type of data, once you know the type of data, you will know what would be the best platform, like the best repository, the best dashboard, the best whatever, where this data could be hosted or shared. Yeah. And standards for data and metadata format and content where existing standards are absent or deemed inadequate. This should be documented along with any proposed solution for this. So standards, like remember we talked, this is about like interoperable. So that will make your data like interoperable because like you using some common standard and vocabulary of your industry. And I give you an example, like let's say like you want to have climate data. The standard for saving climate data is something called like netcdf files. And with their different format, like if I want to save this as like kind of a binary data, not CDF data, like a different type of standard, like a binary data that's not CDF, then that will not be compliance with the industry standard, for example, like with all those climate research. But again, like why metadata is also important. Metadata is important because it makes your work findable. It could be searched by search engine. Why is metadata is important? Because metadata is just like a description of what you're doing, description of your data, description of your step, description of your code. And there is a saying that data is a hungry creature. It's like the more description you provide, the more you can provide on and on and on. Yeah. But it makes your data reusable because if people understand your code, your data, then they will be able to use it. Yeah? Policy for access and sharing. So including provision for appropriate protection of privacy. Okay, so this is very important. Policy for access and sharing, including provision for appropriate protection of privacy, confidentiality, security, intellectual property, and other right of requirements. So let me give you an example from my research. And this is why, because that has to do with also accessibility and reusability. Because if this has intellectual properties, that will affect your license. If this has like a privacy and like privacy or security data, you can that will restrict access to this data. Yeah, so, because remember, not all data should be shared. Like if your company has some confidential data that give it edge over its competitor, you should not share this data. Yeah. But the privacy issue, let me give you an example from my research. So in my research, I did like educational research. Yeah. So in educational research, there could be like a privacy issue. And what do? You like I share the data, but I anonymize it. Like for example, I will not share like student name with a grade. I will just anonymize it. Yeah. So I could share the grade, but you wouldn't know this grade belonged to who. Yeah. It will be anonymized. I did, for example, like respiratory health data. We get this data from the ER. So when the ER give us like this data, emergency room, what do they do? Do they give us like the condition and the name? No, they anonymize it. They remove the name and just give us at this time we got this condition, at this time we got this condition, at this time we got this condition, but you remove the name. So that's very important. Otherwise, you could get yourself in trouble, and you could get your institute in trouble also. Yeah. So that is also like something you need to be careful about. Yeah. Policy and provision for reuse. So here is like specific, like, so this again about like accessibility and reusability for reuse, and plan for archiving the data, like how you plan to make this data available and archivable. Remember, like any research data, you should keep it for at least 5 years. Yeah, that's like the minimum period. If you want to keep it more, but the minimum period is like you should keep it for 5 years for any papers you publish. Yeah. Plan for archiving, like samples and other research product, and the preservation of access. So this has like, for example, I will share my data on HydroShare. Remember HydroShare? This is a repository for hydrology data. Yeah? And we learn about this. If I want to make license for my data, what do I do? Like I can use this one, for example, CC, like Creative Commons. If I want to make like my data like findable, I need to provide some persistent IDs, like a research activity ID, like a project ID, or like a DOI for all the outputs of my research. Yeah. If I want to make my data accessible, also I can use GitHub. I can use also GitHub to provide license to make it like usable. I will show you this in the next video. And if I want to make my data like here standards and practice like interoperable, for example, like I can use Open Geospatial Consortium, like their markup language. Yeah, so they have like a markup language and like some specifications. The markup language. So I can use this, or if I'm using climate data, I can use this CP that I just showed you, like this, whatever climate data markup language or documentation or standard vocabulary. Okay. So here, this is like, this would be like, that would be like the uh, more guidelines. So the data management plan should clearly articulate how the investigator plan to manage a dissemination both physical and digital data generated by the project, taking advantage of information technology. So this is from NSF. Yes, this is not from me. Technology and cyber infrastructure. So I told you the infrastructure is there already. The plan must include sufficient detail of evidence for the appropriateness and feasibility during merit review. And So the data management plan should describe like these things that we just discussed. Yeah. So let's go to Canvas because like let's just review an example together. Yeah. So like if we go to our Canvas course, so as a student you should be able to see something like this. You go to module 5 data management week 10. I mean, I will still update this, but don't worry, like the most important part here is that I just put an example. So that will be this slide. I will upload it later. These are additional material if you like this topic and you want to learn about it, but this is what I want you to see as an example. So here, this is the guidelines that I just presented. So if you want to read the full guideline, you can check this document. But here, this is a mock data management plan. So this is an example of a data management plan. Yeah. So this is a mock data management plan and should look like this. Yeah. So for your project, you can prepare something that looks like this. Yeah. And here I put the questions, the NSF questions that they ask you. So here, like remember, like these 6 things that we like, what type of data or metadata or sample you are planning to collect. So here, I just described like what type of data, like uh, that you are planning to collect. Like we go over this. The data management plan to describe the exact type of data retained, managed, and shared, and the plan for doing so. What description and metadata are needed to make the actual data product useful and reproducible by general researchers? See here, that's we were discussing this. So they're already asking you for this. For collaborative research, the data management plan describes the roles and responsibility of all parts, like who is responsible for what with respect to the management of data. Yeah. And so you see here, I'm explaining like, okay, this is, I'm explaining to get like text data, tabular data, NetCDF file, Python code, Jupyter notebook, figures and video. And then I'm explaining who will do what and the uh, so you can read this. I don't want to make this video long, but it's better like if you just like read this and you see like the level of details. And here I'm like metadata and documentation. I'm explaining what guidelines I will use for like metadata and documentation. You can read this here. And then here the responsibility, like what will the PI do and what will like that would be mainly the responsibility of the PI. Here it's just like the data formats. Like what formats are you expecting? So we are expecting to get netcdf data. We are expecting to get ASCII data. Uh, we are expecting to get CSV data, like spreadsheet type of data. We are expecting to get vector data and like TIFF data for the figure. And you need to also have an idea of like the size of this data to decide on where you want to share it. And now here is the dissemination and access. Like where are you going to share this data, disseminate it, and provide access to it and make it findable? Yeah. So here basically we are saying like we're gonna use like Google Drive. That would be like our main thing, and then we will have it like Google Drive will have like a GitHub interface. The data will be accessible through Google Drive, Colab, and GitHub. I showed you like an example for this. Uh, we will like use DOI, digital object identifier, uh, researcher ID, and we will also have like a project ID and the resource ID for like specific resources that will be used like software or something like that. And here, this is the reuse, redistribution, and product derivative. So basically, we are saying here that like all our data will be CC BY. Like we will not have any restriction on our data. Yeah. Here, ethical privacy and security. No ethical privacy, security, data sensitive issues are expected to affect the data storage and transfer sharing. For your project, it could be different because for your project, you will you could be doing interview, yeah, and you could be doing impersonal interview. So that's what I will be looking for when I grade this part. I will be looking like if your project you are doing impersonal interview, not anonymous like survey or something like this, I would expect you here to write like we'll do in-person interview, the names will be anonymized and personal information will be anonymized. That's it. Yeah, something simple. So that's all simple. And then archiving the data, where will this data be shared? So we will share this data on like, remember this like the Gulf of Mexico Initiative Information and Data Cooperative, like this repository. Why? because this repository is the repository where the data about like the Gulf is conducted, like where research about the Gulf is conducted. So that would be the most appropriate like repository to put this data. If it was a general hydrology, I could also share it on HydroShare, like the hydrology, like this hydrology respiratory repository. But this one I think would be more relevant for this research, yeah, because that's exactly where the Gulf is, like the Gulf research, like research about the Gulf, yeah. And then I will explain preservation. Since collecting and pre-processing the project data is time-consuming task, there will be need to preserve this data. Raw data will be archived and preserved on Gridic, and Gridic repository will be linked to our GitHub repository. So Gridic repositories that will have the big data, GitHub repositories that will be an interface and for light data, like not big size, not huge data. Because again, we don't have a subscription at GitHub. We just use the free version, and usually, so that's another thing you need to think about. Yeah, you need to think about the sustainability of your data. So if you will put it here, this will be, you will host your data for free, but that might not have like the most like user friendly interface, or might not have like features, like for example, like if I want to get a DOI, if I want to get a DOI for my repository, as I will show you like in the next video, that platform will not support this, but GitHub will support this. So I could put the data here, link it to GitHub, and then get like a DOI for my GitHub repository. So instead of like providing the URL of the GitHub, as I as for example I do with this course, like so for example with this course, I just provide like URL, but that's not a good practice. A good practice is you provide a DOI, so I can provide a DOI from my GitHub. Okay. So let's just do like some closing remark before we get into the how of it, like how to do it, how to actually do it, and give you like some hand-on experiences in the next video, like how to do this on GitHub. So the closing remark, like FAIR is a consistent approach to keep my data organized, reusable when I am not present. That's most important thing. When I'm not present, yeah, you don't need to sit with your co-worker or your student or your supervisor or the one who or the one that you are supervising to give him like details. Like everything will be there. You just give him a DOI or a link. Yeah. Make data open as possible. That's very important, and as close as necessarily. So consult with your supervisor. Ask him what should I share and what I should not share to benefit research community and the stakeholder. Uh, FAIR is not like a checklist of compliance, but a change in the research culture. And we talked about like all this transparency and reproducibility issue. And some of you even enjoyed very much this video about like data fabrication and data falsification. If you are using these practices, that will reduce this. And I can tell you, your paper could get rejected for that reason. And you could like as a reviewer, if I feel that something is fishy, I could tell the editor. And you will not know, by the way, because like as a reviewer, you can just tell the editor without like without the author knowing. So I can tell the editor like the user didn't share his data. This part I couldn't like verify or check, but I would recommend that they would share their data or something like this. And then when the editor sees something like this, they might also not feel comfortable. Yeah. Who, so so uh, so it is became like it required, for example, like NIH. This data is started to be a requirement from 2023 that you need to share your data. While you have well organized it and document your data, the rest is available for you. So all you need is that you just organize your data and well documented. The rest is available for you, like repository, persistent identifier, license. These are all available for you, which I will show you in the next video. Yeah. FAIR increase your credibility as a researcher and will increase your citation and benefit the research community and stakeholders. So I think with this, I will end this video. So these are additional resources like some more training and some more paper and some more information about this topic. So here you can like check this additional resources, like you can pause this and learn more about this additional resources. Uh, uh, this is like open science framework. This is again for organizing, like especially if you're doing lab work, that's a very good platform for organizing this. So these are some additional resources if you want to learn about this. Next video, you will learn how to use GitHub to do it. Okay, how to do this on GitHub. Okay.